Thank you, madam. So, my chance to welcome you all. So, I was supposed to be here earlier, but got delayed due to some prayer commitments. So, you already have started the technical session. So, I will also try to be slightly more technical than what I planned, because I planned to have it before the technical sessions. Now, anyway, you have started. So, let us see what is the most important issue while you are facing in say data structures, algorithms, mining, data mining, or almost any field today that you are dealing with computers. One major problem is not yet fully solved, and that perhaps if solved is the only problem. So, I will only talk about that. Suppose we ask the question, so write some number. So, I have written in binary because that is the mode of storage in most modern machines. We ask the question, what is this? So, what will be the answer? Yeah, it could be somebody's age. It could be part of some IP address, it could be part of some text file, it could be part of an image. There is no end to this, it goes on. We ourselves are not able to say what this is. Computer has to say what this is, looking at the data. It has to understand, right? We have to teach the machine to answer this question, what this is. How difficult will we face this problem? And this is the problem. So, you have some data, you are asking what is this? How do you answer this? So, how do you answer? Over the generations we get better and better answers, and that is what we are saying, progress in this field. Some things will be breakthroughs, others will not. Breakthrough means you get a completely different paradigm of how to deal with this. So, I will talk about the first of the breakthroughs, which unfortunately is the last also so far what we know. We did not get another big breakthrough in answering this fundamental thing. So, how do you answer the question what this data is, alright? So, how do you answer? People have used what is known as operational approach. I mean, these are not well known technical terms. This is what we are introducing to convey some idea. Right? If you go into Google search an operational approach, I don't know what you will get. You will get something for sure. Google is too shrewd, right? Because Google is working on the operational approach, so you will get something. Or you can say functional approach. To answer this question of what this is, you don't answer this question directly, you answer what you want to do with it. So, instead of saying what is this data, you ask the question what can I do with this data. And this question is what can I do with this data is much more easier than say what is this data. Then you just say that whatever can be done with this data, the entire set of operations is what defines the data itself. You do not directly answer this question what is the data. You just look at the set of all operations that can ever be done on the data and decide that this set of operations characterizes what the data is. Let us see some examples. Suppose you have int pointer, you have float pointer. So, int pointer is how many bytes of data? Whatever. Yeah. But it is address of one location. What is float pointer? Address of one location. So, data is exactly the same. Data is exactly the same, right? But machine should be able to say whether this data is int pointer or float pointer, otherwise it will get caught. So, how do you decide whether it is int pointer or float pointer even though data is exactly the same? Operational approach. All that you say is I will give you the set of operations that you can do. If you have in pointer say I and float pointer f, if I do increment operation in I and if I do increment operation in f, these operations are not same. If I increase int pointer 1, if the size of int is say 2 bytes, I plus plus means I plus 2, that's the meaning. If float is 4 bytes, f plus plus means f plus 4, that's the meaning. And that is how machine can differentiate between in pointer and float pointer, even though both of them exactly is the same. It is the address of the starting location of the data. The data is exactly the same, but what is the data? Machine can differentiate only on one way so far. Man has found only one way to teach machine how to differentiate two data, even though the data is same. It can do it the operational way. What you do on the data, if it is different, the data is different. So how do you say data is different? So they use the term type. So what is this? You look at what can be done on this, and whatever is that set, you call it, it is that type. So you have data type. And data type is the way today we answer the question of what is this. So if that was IP address, you say it's IP address type. If that is float, you say that is float type. If that is int, you say it is int type. But have you actually taught the machine what is integer, what is float? No, not at all. What we have taught the machine is what you can do with that. So if it is integer, what all you can do? You can add, you can subtract, you can multiply, you can. If it is float, what all you can do? It will be different set of operations, and so on. This was the first breakthrough. Notice that this data type could be abstract also. That is, it can be created. So integer, float, and all are there. Mankind much before computers came. But after computers came, you have several other data types. Linked list is a data type. What do you mean by linked list data type? You have the data all right, but the set of operations you can do on that defines what that is. You can insert, you can delete, you can find. This forms a list. If you can delete min and you can insert, this forms a priority queue. How to implement that? You can use a heap to implement that. You can implement it in array. Different implementations have different characteristics. All that based on application and the frequency of the operations, you will know which one to implement where. But the set of operations that you can do on the data defines the data type, and that is what we use to answer what this. This was a breakthrough with respect to programming, with respect to data structures, but unfortunately it is a stumbling block when we come to teaching machine how to discover knowledge from data. When it comes to discovering new knowledge from data, you cannot depend on teaching the machine operational meaning of what data is itself. So whatever you do on the data is what you are saying is the data type. And now you are saying discover something from the data that I have given. How will it do? So that is the struggle we have. Till date, we have only operational definitions of things. Not only in data. All of computer science, you take everywhere you go, we define things operationally. Humans can work both ways. I don't think we define data only operationally. If you say that this is the age, our definition of what age is, the way we understand is not actually, oh age, that means I can only add, I cannot reduce it, it should be positive. That's not the way we think. We don't define age as a number which lies between 0 and 100, which cannot be negative, and a set of operational things, what all you can do with that, right? I cannot add age, I should increment only by 1 every year. I mean, these are all the operational definitions, and that's how computer deals with age. Yeah. So we don't deal with, for us age means something else. We always do not use, say, operational definition of things. We use it only when that actually is the need of the hour. And when man made machines, it was the need of the hour, and man started using operational definitions more and more because of interacting with machines. Machine till date uses only operational definitions, and we are in a struggle with it to see how to go beyond operational definition of what data is itself, so that you can discover knowledge from data. More on this you can see throughout the session. Two main aspects of going beyond this. People have tried, say, classification, clustering. Both are essentially the same, with clustering being slightly more tougher. Let us see why. So you have to classify data without having to specify the classes beforehand, that is clustering. Without specifying what the classes are beforehand, you look at the data and find out the classes on your own and then classify. So that is clustering. Now that means it's slightly beyond operational. You are not even saying, so it will say this is the age, that is the float, this is int, the machine will say on its own. It will put data in different clusters without even knowing what, before looking at the data it doesn't even know what clusters will come. It will, looking at the data it will decide, oh these are what is given to me, and it classify them. So classification is subset of clustering. Classification is clustering where you already know the classes. If you don't even know the classes, it is a tougher classification, that's given new name, clustering. So these are two things. So you will see most of the sessions will deal with either classification or clustering or mix and match of both. Alright, so technical sessions later. So I'll just stop here with some motivation for why we are doing all this. So we know that we are living in a huge universe, right? Very, very big universe. You know how big is universe? Very big. There are billion galaxies known. Each galaxy is very big, having 100 billion stars known in each galaxy on average. We live in one such galaxy with one such star called the Sun. It is not even in the center of the Milky Way, our galaxy. It is somewhere in the corner. That has some 8 to 9 planets. There is a dispute in how many. And then we are living in the third planet of that. That is not even the biggest planet of that. It is not even in the center. It is some small planet. In that planet there are several million living species. We are one of them. That is, human race itself is one of them. I as an individual is one among several people who are lived in the past, who are going to live in the future. Universe has been there for 13 billion years. I am going to live for 100 years. Look at this. Look at the contrast. Universe is billions of light years in diameter. I mean, the space I can cover in my entire 100 years itself, even if I travel at speed of light, is not much, but I know that I cannot go beyond Earth maybe in lifetime. So this space coverage, temporally, spatially, all things gives enough evidence that we are a speck in the universe. We have to argue that we are not later, but we are a speck in the universe. Whether a speck does research or not, leave alone research in data mining per se. What difference does it make? Suppose I lead a life, I get up in the morning, don't do anything, and then life goes that way, 100 years passes. There's some other person, he gets up in the morning, does a lot of work, everything, 100 years passes, he also goes away. What is the difference between these two? So, in the universe scheme of things, whether a person worked hard in his life and succeeded, person did research or not, or a person didn't do research, what difference does it make to the universe? Somebody in small part of it which is not visible to any person far off, extraterrestrial may not be able to see with very high advanced technology it's required to see us. So whether I get up in the morning at dawn, brush my teeth, live a very pious life, succeed, all this should have meaning, but our rhetoric we used to describe the universe is showing actually the reverse. It has no meaning, but it should, right? It does. We'll argue, we'll change the rhetoric. So far we have been looking at 2 dimensions, space and time. In those 2 dimensions, humans are a speck. Unfortunately, they are. You cannot deny that. The amount, if you say the overall space that universe is, we are a speck. Overall time of the universe, we are a speck. But are space and time the dominant parameters of the universe? Unfortunately, or fortunately, we don't know. My opinion is no. Fortunately, space and time are not the dominant parameters of judging the universe. They are one of the parameters, but not the dominant ones. What is the dominant one? Let us see. So what made humans special on Earth? We'll find that out, and we'll argue that the same thing nearly, when extended, makes them special in the entire universe, if not beyond. So what makes them special on Earth? If there is 2 dogs are walking, one dog gets caught in quicksand, what will the other dog do? Cannot say. If 2 people are going, one person gets caught in quicksand, what will the other person do? help him out. As simple as that. So if two animals are going, one animal is suffering, is easy to help, but the other animal cannot. Why can't the other animal help? Consciousness, maybe it's conscious. Done now. So suppose two people are traveling, one person got caught in quicksand, we help him out. How are we able to help him out? We know how to help him out. That is why. Do we always know how to help people? No. There is a lurking problem. I'll tell you the problem. Sun is going to be there for, after that sun is going to disappear. It's lurking. Within in the time of universe, 5 billion years is nothing. Universe is going to be there for much longer. We know now that sun is going to be there for only 5 billion years. It's a problem to solve. How should we help the entire biosphere to survive even after sun disappears? That's the help. How to help that? We don't know. We don't have the knowledge. So as knowledge increases, the ability to help increases, and help can only be given in what we have seen by humans. It could be that others also can help, but humans are able to help specially only because of one parameter. Humans have more knowledge. Not all humans can help in the same way. Intention apart, let us say that is always good. Even if your intention is good, not all people can help in the same way. Difference is in knowledge. How to take a person out of quicksand, you should have the knowledge. Then you can do that. How to increase the lifetime of sun, we don't have the knowledge. Therefore, we are not able to help. But if you have the knowledge, you can. But that knowledge also is necessary. Therefore, as knowledge grows, the more help you can do. Now, why is this a dominant parameter, or why is knowledge a dominant parameter? So, if an asteroid strikes Jupiter, which is much bigger than Earth, can Jupiter stop it? If asteroid is bombarding Jupiter, Jupiter is massive, way bigger than Earth. It is there for longer time perhaps. Both in space as well as time, Jupiter is much bigger than Earth. But it cannot stop one asteroid strike on it. But Earth as of today, or say 100 years later, can an asteroid strike Earth? No. Cannot. Earth is small. It could have been even smaller, doesn't matter. But an asteroid cannot strike Earth. In fact, it can't even strike Jupiter if Earth can stop it. So Jupiter may be big, may be large, but if an asteroid strikes it, it has to ask Earth for help. Kindly stop it. Only Earth can help. Only Earth can help anybody in this known universe that we have known so far. We need not be alone, but we are close to Jupiter. Jupiter can ask help only from Earth. That's if it wants to survive for longer. Same case with Sun. If Sun wants to survive for longer, Earth is the only planet which can help for it to survive for 100 billion years. If Earth wants, it can. Today it cannot, but we have 5 billion years time to find out how to increase that. In that we will do that. So dominant parameter with respect to who is important in the universe is neither time nor space. It is knowledge. It is knowledge. And what is knowledge? That which will increase your tendency to help, of course. I mean, you have more knowledge means you should be able to help more people, because we have seen that help is the unique starting point. We need to increase the knowledge. That is the dominant force. In this parameter, certainly Earth is very big in the universe, not small. Earth is no longer a speck. Earth was a speck in the parameter of space, yes. Earth was a speck in the parameter of time, yes. Is Earth a speck in the parameter of knowledge? No. It is not a speck. It is a dominant force in the universe. Knowledge parameter is a more dominant parameter, so Earth is not a speck. And on Earth, humans are not a speck. Humans are the dominant species because they have the highest knowledge. And one individual human being also is not a speck in the knowledge parameter. There are usually 3 kinds to pursue knowledge: Satyam, Shivam, Sundaram. Right? People pursue knowledge by pursuing what is true, keeping the other things apart. That is, It does not matter whether it, Shivam means it is good for the society or the helping hand. Sundaram means it is innate beauty, innate happiness. So keeping aside Shivam and Sundaram part, if you are putting truth as the pedestal, that is, I don't worry even if it is not helpful to society. I don't worry if it is not beautiful or it is ugly. That's not my goal. I just want to see whether it's true or not. That is one way of pursuing knowledge. This we call science today. So I want to know what is truth. It does not matter whether it is beautiful. Even ugly science also is science, as long as it's true. It does not matter whether it is going to improve things or not. As long as it is true, we are pursuing that. That is one way to pursue. So these are separated because it is very tough to pursue all these things together, right? So they are classified. This is a classification. So you pursue knowledge, you create new truths or discover new truths. There is a Shivam part. We call it technology today. So you help the society. Society could not just be our territory or our world, the entire universe. So build technologies which will make life better across the universe. So that is Shivam kind of pursuing knowledge. There is of course art, the Sundaram kind of pursuing knowledge. You innately pursue knowledge within yourself, that makes you happy because of the innate beauty that is involved there. So beauty, love and other things also are forms of pursuing knowledge, the Sundaram way. We call it humanities, art, and several names are there in universities today. There is science, there is technology, there is humanities. So very rarely we find that we get an opportunity to pursue all the three in one shot, right? Advent of computer science is going to change that, I believe. So computers are the one which can be simultaneously elegant, beautiful, artistic, helpful to society, changing everything around and discovering new truths. So computer science is going to be a special field in the future. One of the very few fields which is Satyam, Shivam and Sundaram simultaneously, right? So we should be working towards making computer science do this, but of course our attitude always is we are not a speck in the universe. We are here to do big things. We are rare species which has knowledge, and we have to increase that knowledge continuously. Research will help us do that, whether research in data mining or research in security or any research will help us add to that knowledge continuously, and that is what defines us as not being a speck. If you get up in the morning, not do anything, sleep every day and spend 100 years like that, you are a speck, because already in space time we are a speck. We know it is quite 100 years that we have. We should not be a speck means either we should create knowledge which itself will improve the amount of help we can do to people in the future, or directly help with the current knowledge. So knowledge is required only to help the universe at the end of the day. So if you are good at taking the current knowledge and helping the universe directly, do that. That is directly going to the helping field. Or create new knowledge which will eventually go on help people later on, right? So we are not here to be a speck in the universe, though in the rhetoric of space and time we are forced to be that. In knowledge base, in the ability to help others, we are a dominant force in the universe, and with the belief that knowledge and helping nature are the dominant parameters of presenting a universe, we will find that Earth is a very, very big thing for the universe. Universe is happy to have Earth. In space and time it may be small, but because of the knowledge that Earth can give the universe and the help that Earth can give the universe, Earth is much, much bigger, right? So I will stop here.